Now let's take a look at converting from rectangular coordinates to polar coordinates. So let's say our rectangular point is 0, 3. Let me just graph it. This is our x and y coordinate. 1, 2, 3. So it would be right here, 0, 3. Okay, that's our point. Now we want to find the polar coordinates. So let's take a look. We have r squared is equal to 0 squared plus positive 3 squared. So r squared is equal to 9, and that makes r the square root of 9, which is 3. So r is 3. And now let's take a look at the angle. I mean, we can already see what the angle is here based on our graph. The tangent theta is y, which is 3 over 0. And at what angle is the tangent undefined? Well, that is at pi over 2. So we have the angle pi over 2. That means my polar coordinates for this point are 3 comma pi over 2. Okay, not too bad. Now let's take a look at a different point. One more, why not? Let's say we have the rectangular coordinates 2 comma negative 2, and we want to change them into polar coordinates. Always make sure that you know which quadrant you are. 2, negative 2, so we are in quadrant 4 in this case. Okay, let's find r first. R squared equals 2 squared plus negative 2 squared, which is 4 plus 4, so r squared is equal to 8. If you take the square root of 8, that means r is 2 square root of 2. Okay, let's find the angle. So tangent theta equals y over x, which is negative 2 over 2. So tangent theta negative 1. So now for which angle? So we have to take the inverse tangent of negative 1. Okay, if you use your calculator, negative 1, you will see or know it from when we talked about the inverse function that theta is equal to a negative pi over 4, 45 degrees. So that means, oops, there's a 4 here. So my polar coordinates are 2 square root of 2 and negative pi over 4. Now, if you want to get another point that is in the same in quadrant 4, you add 8 pi over 4 to it, 2 pi, which gives you 2 square root of 2. Negative 1 plus 8 is 7 pi over 4. Here you go. That's it. Of course, there are other versions of this point.